Hey guys, so welcome back to another video. Today I'm going to be talking about partial fractions. And so as you can see up on the blackboard, I have 4 different cases of partial fractions that are organized by denominator. And so I'm going to use like some examples about what they would look like. So now for what to do in each of these cases, what we're going to try and do is so for case 1, this one is like our favorite case because this is what we can do in this case is we can just take this identity and roll with it, because since it's only a linear denominator, we can do a linear substitution, right? And so that's pretty straightforward. It gets a little bit trickier when we hit case 2 because now we have a linear function to some power, right? And so we might initially want to like, okay, well, I can just like multiply stuff out, but like we don't want to do that because like let's say we end up with a power of like 4 or 5, it gets super tedious and kind of impractical. So here's when we would start to break it up into partial fractions, right? Because we have the linear denominator to the power of k, that means we're going to have k different fractions, right? So when we break up this fraction, we're going to have something that looks like a1 over ax plus b plus a2 over ax plus b squared plus, and then we're just going to keep going until finally we get to ak over ax plus b to the power of k, right? And so we're just going to keep adding on those fractions, keep adding on like some numerators until we hit k. So like for this example in the white that I've given down here, since I have it to the power, since my linear denominator is to the power of 3, what I would get is I would have something like a1 over 2x plus 3 plus a2 over 2x plus 3 squared plus a3 over 2x plus 3 cubed. And once I'm at cubed, I'm done, right? So the third case is also a case that we like. Basically, if we have a quadratic in the denominator, what we want is for that quadratic to be factorable. If we can factor that quadratic, what we would get is we would get something that's like b1 over ax plus b plus b2 over cx plus d, right? With these two things multiplied together, will give you ax squared plus bx plus c. Also note, I chose these letters poorly, but these A, B, C's, and D's don't necessarily have to match these ones. And so this is when we would have like those two separate denominators, and then we would solve for A, B, C, D, B1, B2 by cross multiplying. And I prefer just doing a straight system of equations, but do whatever makes you feel happy or that you understand, right? And then for case number 4, same thing as case number 2, where first we're going to have to write them all into separate sums, right? So first we're going to have something like c1 over ax squared plus bx plus c plus c2 over ax squared plus bx plus c, all of this squared, plus all the way until you get to ck over ax squared plus bx plus c, all of that to the power of k, right? So those are kind of the 4 main cases. So just remember, the biggest takeaways from this is when you have a power in the denominator, you have to count up to that power. And every time you count up to that power, you're going to have different numerators for each of your fractions. Also remember that for partial fractions, we can only really do this if your numerator is a smaller degree than the denominator. So if your numerator has a higher degree than the denominator, you have to use synthetic division, or long division, whichever you prefer, to make it so that your degree on top is smaller than the degree on the bottom. So yeah, anyways, that's it for me. I hope this was a good review for you guys. I hope you learned something. So thanks for watching.